period. Hopefully I do a good job. So I'll have a good recording. If not, I'll try again during sixth period. Put the pressure on. Actually, I did record my first period class today and it's like okay. So I do have that. So it's not too much pressure. I could post first period. I'd give my first period performance like a B plus, but I'd like to get an A. Okay, so let's go ahead and get started here. But before we do, I just wanted to tell you guys that like I was hanging out yesterday. It's Wednesday. I was working from home. I did a little bit of tutoring. A couple people came to my tutoring session, and I got kind of bummed out. I was kind of like sad and the reason I was sad is because I was thinking like, man, in pre-calculus we've been like working with all these right triangles, right? And right triangles are awesome because right triangles we have so many tools to like find missing sides and angles on right triangles, right? Like we have Pythagorean theorem. If we have two sides on a right triangle, we can find the third side. We have SOHCAHTOA. If we know like one angle and one side, we can find everything using SOHCAHTOA, right? And so that I was happy about that, but then I got bummed. I got kind of sad because I was like, oh my gosh, what about non-right triangles? Like those tools do not work on non-right triangles. And I see so many non-right triangles in the world, and I'm like, what if I wanted to find missing sides and angles on non-right triangles? What am I going to do? And then I remembered, then I wasn't so sad anymore because I remembered law of sines. Okay, so that's what we're going to learn about today. Law of sines. And law of sines, as you can see on our essential question, is all about finding sides and angles on a non-right triangle. So we should probably make a quick note here off to the side. So side note here. SOHCAHTOA and Pythagorean theorem, both of which we love, but they're only for right triangles. So they're only for right triangles. That's why right triangles are so awesome, because we do have so many tools to work with those. Okay. So what we're going to learn today is called the law of sines. We are still going to be using sine, okay, but it's not really opposite over hypotenuse anymore. We're going to use sine in a different application that works for all triangles, not just right triangles, okay? And it makes sense that these only work for right triangles because they both kind of call out the hypotenuse, right? Like SOHCAHTOA, those H's are the hypotenuse. And then we know on Pythagorean theorem, the C has to be the hypotenuse. And so if we're the hypotenuse is the side opposite the right angle. So if we have no right angle, we have no hypotenuse, then of course these are not going to work, right? Okay, so what is the law of sines? All right, well, the law of sines, I'm going to scroll down here and this to the formula is right here. It's actually pretty easy to work with. I think it looks a little scary, but it's not that bad. So here's the formula, kind of how I see it. The sine of any angle over its opposite side is equal to the sine of any other angle over its opposite side. So they say angle alpha is opposite side A, angle bravo is opposite side B, and angle gamma is opposite side C. They call this one gamma because I think gamma is the third letter in the Greek alphabet, so that's why they match it up with C. I sometimes see this as like sine of big A over little a equals sine of big B over little b equals sine of big C over little c. You could write it like that as well. And so that's our formula here, okay? Now, what's a little weird here, usually with a formula, we don't have two equal signs, like we don't have three pieces to a formula, three sides. I'll tell you right now, we're not going to use all three fractions at the same time. We're going to be pairing up two at a time, okay? But what it's trying to say here is you can pair up any two you want. So you could do sine of alpha over little a equals sine of bravo over little b, or you could do sine of alpha over little a equals sine of gamma over little c. So you can pair these up however you like, okay? One more thing, you may see it written like this. I included this over here where they're all upside down because I've taught it. I always teach it this way because that's how kind of I see it. And then I've had students that like say, hey, Mr. Bear, I saw on the internet law of signs is actually like this. So checkmate, you're wrong. And I'm like, well, checkmate to you because that's equivalent. Like I'm not wrong. It's just that's also right. So if you flip everything upside down, it'll still work, okay? I don't know why you would do that, but you could. All right. Awesome. So this right here tells you which kind of cases you're going to use this in. I would actually let's not worry about that for now. I will tell you, like, when we get on to next section, we're going to talk about what to do when law of signs does not work and how to tell that law of signs does not work. For this section, let's just assume that law of signs is going to work on all of these because it's literally the law of signs section. So yeah, that's going to be good. You guys might have used this formula in geometry. You might have also used it in Algebra 2 trig. I think it's more likely you did it in geometry, but either way, if you did or didn't, I'll kind of introduce it like it's new anyway, because I know it's been a long time. So let's just go for it, okay? Ambiguous case, I think we're going to skip that. If we do it, we'll do it later, but for today, at least we'll skip that and maybe forever. Okay. So let's come down here and do some problems. It's fun stuff. Okay, so they've given us 3 pieces of information here, and they are asking us to solve the triangle. So we know solving the triangle is 6 pieces of information. We need 3 angles and 3 sides. So I'm just going to start off by drawing a triangle here. And I would also assume that all the triangles in this section are non-right triangles, since that's what it's really all about. So you can label whichever sides you want. So I'll go ahead and label this one alpha, that one bravo, and then this one gamma, which I always have a hard time drawing. I don't think I did a good job there. That's a little better. Okay, so let's fill out what we know. We know that alpha is 15 degrees. We know that gamma is 35 degrees. And then we know that side B is 42. So side B is going to be opposite the angle bravo, okay? Okay, so in order to use law of signs, what's super crucial about law of signs is that you have one kind of completed pair. So completed pair, what I mean by that is you know one angle with that angle's opposite side. Both of those are known values, okay? I'm actually going to say right now, we do not have a completed pair. We do not know any of these angles with their opposite sides. We know angle alpha, but we don't know side A. We know angle gamma, but we don't know side C. We know side B, but we don't know angle beta, okay? So we're kind of striking out here. So we're actually not able to use law of signs right now, all right? But good news, there is a way we can find another piece of information right now without using law of signs. And it's actually really easy, all right? Anytime we know 2 angles on a triangle, we can always figure out the 3rd angle, correct? So we can always we know there's 180 degrees total in a triangle. We subtract out the 2 that we know, and we get the 3rd one. I should be able to do this in my head. Yes, it's 130. So we find the first piece of information, the missing angle, the only missing angle, not using law of signs, but using 180 minus the other 2 angles, correct? Okay. So now we know one completed pair. We know one angle with its opposite side, right? So now we're ready to use law of signs. So I'm going to start it off here by creating my complete fraction. So sine of an angle, so sine of 130 over 42, its opposite side, equals. And now I can either find side A first or side C first. It really doesn't matter. I'm going to have to find both of them using the same technique anyway. So I'll go ahead and find side A first. So to find side A then, I'm going to put that on bottom. And on top of it, I have to put sine of its opposite angle. So that's going to be sine of 15. Like I said, we're not going to set this equal to another fraction. We kind of just pair these fractions up two at a time. So now I need to solve this equation, okay? So for solving, this is called a proportion, or solving two fractions equal to each other. The most popular technique is you do this one times that one equals that one times that one. They call this cross multiplication, sometimes called the butterfly or la mariposa multiplicación, if you'd like to draw a little butterfly right there. See it? That's good. I guess it looks more like a dragonfly, actually. All right. So I said we're going to do 42 times sine of 15 equals a times sine of 130. All right, so we're trying to isolate a here, so we would divide the sine 130 over to the other side. Cancel that out. Okay. Quick note here. I've seen some students, they try to like reduce the 15 over 130. Don't do that, especially if it was like 10 over 130. Students want to cross off a 0. You can't reduce with numbers that are inside of a sign, okay? So don't ever, if you had numbers out front, you actually could reduce those, but numbers inside of a sign, you cannot reduce, okay? Or a tan or a cosine or any of that stuff. So from here, I'm just going to type that in my calculator now, and I'm going to get a decimal answer, and I'm going to be done finding side A. Now, since we're doing sine of degrees here, we have to make sure that our calculator is in degree mode, correct? So on Desmos, I know Desmos defaults to radian mode, so make sure you change your mode on Desmos. If you're using your handheld calculator, just double check that it's in degree mode. We've talked about that before. So 42 times sine 15 divided by sine 130. And I get that side A is, I'll call that 14.2. We'll go ahead and round to the first decimal place here for our answers. Remember that WebAssign, they kind of tell you where to round, so just be kind of aware of that. Most of these are going to be decimal answers, so just make sure you're checking where we're rounding to, okay? Okay, so we found side A. We found angle Bravo. So the last piece of information we need to find is side C. So let's go ahead and find side C now. How are we going to find side C? Well, could we use Pythagorean theorem since we know two sides now? No. Why not? Because remember, Pythagorean theorem only works for right triangles, and this is not a right triangle. So how are we going to find side C? Well, it's going to be almost the same as how we found side A. So this one we're going to do our known fraction, so sine of 130 over 42. Now for my known fraction this time, could I have used sine of 15 over 14.2? I actually could have, right? Because now those are both known. I usually use the given information for a couple of reasons. First of all, that 14.2 is rounded. And so it's going to be more accurate if I use the original given information that was not rounded. Secondly, if I happen to make a mistake finding side A, and then I use that to find side C, like that mistake's going to carry over, right? Whereas if I go back to the given information, I could still do that one correct, even if I did the first one incorrect. So a couple advantages there. But if you did everything right, it should still work. It'll give you close enough to an answer that WebAssign will mark it correct, okay? All right, so now we're going to set this equal to sine of 35 over side C. All right. Now we're gonna do our cross multiply again, but I'll do a little pro tip here that I'll bet a lot of you already knew. So whenever I do these, I kind of just visualize, like when I cross multiply, I just circle the two that I know. So I'm gonna do this one times this one, and then I divide it by the other one that I know. So I always just set it up as C equals 42 sine 35, and then divided by sine 130. If you don't like that and you want to do your full cross multiplication and then divide the sine 130 over, then please feel free to do that. But I know most people kind of like shortcuts, so I wanted to show you that one, okay? Okay, so 42 sine 35 divided by sine 130. Now we're just typing in the calculator. And so I get that side C equals 31.4, let's call it. Okay. All right. Now we are done, but I always like to double check on these. Something I told you guys about was the properties of triangles that states that the biggest side is always opposite the biggest angle, the smallest with the smallest, and the middle with the middle, right? And so that's a great way to check your work on this. So we know that 130 is the biggest angle, and is 42 opposite it? Is that the biggest side? Yes, it is. We see that 15 is the smallest angle, and the opposite side, 14.2, is the smallest side. And then 35 is the middle one, and 31.4 is the middle side. So that does all work out there, right? Awesome. All right, law of sines, y'all. We found all the sides and angles. Hallelujah. All right, eureka, more accurately. All right, let's move on to number 2. Number 2 is going to be a little bit different, so make sure you stick with me here. All right, so let's dibujar un triángulo otra vez. I have angle alpha is 45 degrees, and then its opposite side is 7 rad 2. We don't know angle bravo, but we know the opposite side is 7. And then angle gamma and side C are both unknown. Okay, so number 1, the first thing we did was we did 180 minus the 2 angles that we knew to get the third angle. Can we do that here? No, because we don't know 2 angles, right? We only know 1 angle. So that's out. Oh, secondly, I was going to mention this. Some people might be thinking, hey, Mr. Barry, I think this is a 45, 45, 90 triangle, because isn't a 45, 45, 90 triangle, doesn't it have like a rad 2 in there, right? And I'm going to tell you this is not that, okay? They faked you out. And the reason I know that is on the 45, 45, 90 triangle, the rad 2 piece is the hypotenuse. It's opposite the 90 degrees. It's not opposite the 45 degrees. So it's a fake 45, 45, 90 triangle. Lastly, this section's the law of sines, which means it's probably non-right triangle. And obviously 45, 45, 90 is a right triangle, okay? All right, so what was I going to say then? All right, so we can't do 180 minus to find the other angle. So what are we going to do? Well, I already have a complete fraction here, right? I have a complete pair, an angle with its opposite side. So I'm going to set up that fraction as sine of 45 over 7 rad 2. And then I have one incomplete fraction. So I know 7 as a side, but I don't know its opposite angle. So I'm going to put sine of bravo. And so I can still use this if what I'm missing is the angle, okay? As long as I'm only missing one piece of information in this proportion, it should still work. All right, so let's do our cross multiply here, see what happens. So I'm going to multiply the 2 things that I know, these 2. 7 times sine 45 over, and then divide the other thing, 7 rad 2. But instead of equaling bravo, it's going to equal sine of bravo. Okay, so first of all, I told you guys that we weren't allowed to cancel stuff down that's inside of a sine, but I said if you have stuff out front, you actually can cancel it down. So I'm actually going to cancel out those 7s. All right, and then how do I get rid of the sine? Well, we did kind of briefly mention this in 6.2, but we're going to talk about it more here. You always use a sine inverse, okay? So a sine inverse gets rid of a sine. And so this side will just be left with angle B. So on this side, now I just have to type in the calculator sine inverse of sine 45 over 2, okay? Now I'm typing that in the calculator. I'll tell you that anytime you're looking for an angle in these, you should have to use a sine inverse. So when I typed this into the calculator, I got 30. Okay, so we got our second angle using law of sines, using a sine inverse in law of sines. Whenever I have two angles, I would always do 180 minus to find the third angle here. So we're going to do 180 minus 45 minus 30. That'll be 105. And then lastly, we need to find side C. So we're going to use law of sines for that again. So I'm going to use sine 30 over 7 for my complete fraction. I know I just said on the previous problem I like to use the given information for my complete fraction, but I don't love that 7 rad 2 right there. Yeah, it's like two things multiplying, and I don't like that. So I'm going to do sine 30 over 7 equals sine 105 over little c. And I'll cross multiply this. So I'm going to have little c equals 7 times sine 105 divided by sine 30. So that I'm just going to type in the calculator. You guys know what sine of 30 is? For me, I started to lose my hair. That was a sine of 30. Get it? That was a joke. All right. So we got 7 sine 105 divided by sine 30. I actually know that sine 30 is 1/2 because of the unit circle, right? Okay, so we get side C is 13.5. Put that there. So does this triangle follow Mr. Berry's rule of small with small, big with big, medium with medium? Well, I kind of need to know the decimal for 7 rad 2. If you type 7 rad 2 into the calculator, it is about 9.9. So then I would say it does follow my rule. So 105 degrees is opposite of 13.5. The big one is opposite of the big one. 30 is the small one, and that's opposite 7, which is the small one. And then 45 is a medium with 9.9 as a medium. Okay, good. All right, let's do number 3. I do want you to pay attention to number 3 here because there's a cool trick here, a good shortcut on number 3 that I wanted to show you, which is why I included it. All right, so same kind of setup here for number 3. The shortcut's going to come near the end. Okay, so this is very similar to number 2, where we only know one angle, but we do know that angle's opposite side. So we can just go ahead and jump right into law of sines here. So I'm going to do my completed fraction. Sine of 100 over 115 equals sine of Bravo over 75. I'll go ahead and do my cross multiplication here. So that'll be 75 times sine of 100 divided by, whoopsie, 115 equals sine of Bravo. Because I'm looking for an angle here, I know I'm going to have to use sine inverse, right? And also because I'm trying to get rid of a sine right now. So to get rid of a sine, you do a sine inverse. To get rid of a cosine, you would do a cosine inverse, right? If you had one. And then you guys know how you get rid of a tan? You just stay indoors for a few months, and that's how you get rid of a tan. Boom! All right, that was another joke. All right, so we end up with Bravo over here. Let's type in the calculator, sine inverse of 75 sine 100 divided by 115, not sine of 115, just 115. And I get an answer that's close enough to 40 degrees that I'm just going to call that 40 degrees. It's actually 39.96, but I'm going to go ahead and round that up to 40 if that's all right. I'm sure if one of you got like a 79.96, you would want me to round that up to an 80, correct? For your percentage in the class. All right. So I would. Some students though ask me to like round a 77.96 up to an 80, and I'm like, no, that's not how rounding works. Okay, so we know then that this angle over here is 40 degrees. So now, now that I have two angles, just like number 2, I would do 180 minus those two angles. To find the last angle, so that means that that last angle is 40 degrees as well. So now to find side C, I could use law of sines, or I could do this. I could just say C equals 75 and be done with it. How about that? Without using law of sines. How did I know that C was 75? Well, I actually, based on my last calculation, realized that this was an isosceles triangle. How did I know that this was an isosceles triangle? Well, a lot of people talk about how an isosceles triangle, two sides are the same, and that's true. But what often is forgotten is that that also means that two angles are the same. So at the moment you realize two angles are the same, you can know that their opposite sides are the same, okay? It actually makes a lot of sense with my kind of always check of biggest side opposite the biggest angle, smallest with the smallest, and middle with the middle, right? Well, if you have two angles that are the same, of course, then their opposite sides should be the same, right? So that's a little shortcut I want to show you. I actually do think we have one problem on this week's WebAssign, on this section's WebAssign, where that does happen, where you can get two angles that are the same, and then you can skip a step at the end and just realize that they are the same sides as well. Now, what if you didn't catch it and you accidentally did law of sines to figure it out? You're still going to get the right answer. So that's not wrong to do it that way. I'm just saying this way is quicker and easier if you can catch it, right? Okay, let's go ahead and skip number 4. Let's do some word problems now. And I use word problems loosely because they actually have pictures on them. So it's not really a word problem. Like really the only thing you need to read here, it says approximate the distance from A to C. So we need to find this side right there, right? Everything else they've labeled on the picture, which is nice because I'm barely literate. Okay, so we need to find that side X. So these people have like measured some distance, a distance and some angles on one side of the river, and they're going to use that to find the distance across the river. So we need to use law of sines to help them, right? Okay, do we have an angle with its opposite side already known? The answer is no. The only side we know is this one, and we don't know its opposite angle. But anytime we have two angles, we can always do 180 minus to find the other angle, right? $46. Okay, so now we can set up a complete fraction here. Sine of 46 over 200. equals, and on all the other ones, we had to find both the other sides. So I said it doesn't really matter which one you do first. On this one, we really only need to find that side x, right? And so I would say we should definitely do that one first. Because once we have that one done, we don't even need to find the other one. We'll be done, right? So this will be 200 times sine of 52 divided by sine of 46. So I get in my calculator 219.1 feet. Is that answer logical? I would argue yes, because 46 is a little bit smaller than 52. And so 200 is a little bit smaller than 219. Awesome. All right, let's do one more. So we got a pilot here. He's flying over a highway. You got 2 mileposts that are 5 miles apart. He's got his angle of depression to each one of them. And they want to know the elevation of the plane, okay? So the elevation is like a vertical distance right here, perpendicular to the ground. But I actually don't want to measure it right there, because if I draw it right there, I'm like breaking apart this big right triangle in the middle here. And I think I'm going to need that big the big non-right triangle in the middle here. And I'm going to need that big non-right triangle in the middle to help figure this out. So I'm actually going to draw this over here. You can see it's the same distance. I'm going to call that x. In order to find x, I'm actually going to find a first. I'm going to find that side right there that I've labeled a. And that's going to lead me to x. All right, so how am I going to find a? Well, I know that this is 5 miles right here, so it would be very valuable for me in law of sines to know this angle over here. And I actually think I can figure that out. We see this blue line is a straight line, and we know a straight line is 180 degrees. So just like a triangle, if I have 3 angles in a straight line, I can subtract the other 2 from 180 to find the third angle. And so this one looks like it's exactly 100 degrees, right? That's good. Now I can actually also know that this angle is 32 degrees right there. And then this angle is 48 degrees right there. How do I know that? Well, I know that because I taught geometry in Hawaii for 1 semester 10 years ago. And I remember everything I've ever, I have like a photographic memory. So when I taught that once, now I remember it forever. Okay, cool. And in geometry, you learn, remember alternate interior angles? These are alternate interior angles. Yeah, I love those alternate interior angles, okay? Also, I think I told you in 6.2 that the angle of depression from something looking down to a point is always the same as the angle of elevation from the bottom looking back up. Those are always equal, okay? All right, so this allows me to build a law of sines here. I'm going to do sine of 100 over 5 equals sine of 48 over a. I'll cross multiply that. 5 times sine 48 divided by sine of 100 equals a. All right, so I got side A at 3.773. I'm going to take that out 3 digits this time because that's not my final answer. I'm going to keep working with it. So now I'm looking over here. I want to find side x. I know this side is 3.773, and I know that angle is 32. But I see now this is a right triangle up here that I'm looking at, correct? So with a right triangle, I can go back to my regular sine equals opposite over hypotenuse, right? I can't use that on a non-right triangle, but like I said, this is a right triangle. So I can say sine of 32 equals x over 3.773. Can multiply that over to the other side. .773 times sine 32. And that answer is so close to 2 that I'm going to go ahead and call it 2 miles. Awesome. So definitely a multi-step problem there, but it was fun. All right.